array method that we used earlier to intersect array with geometry object in the scene and calculate the texture coordinates using pericentric coordinates. We'll pass this time the coordinates x and y from the two loops, and once the color has been returned, we'll make sure that the R, G and B channels have been clamped correctly to 255, because if we have multiple light sources, the surface point could be illuminated to values higher than 255. In that case, we have to clamp them. For the alpha, we're going to use a very similar code, but instead of comparing to 255, we'll compare to 0, because at this point we're not going to deal with transparency of geometry. We'll only assume that the background has an alpha of 0 and any geometry has an alpha of 255. If a value greater than 0 has been returned, then this color corresponds to some geometry surface. Once we have the colors clamped, we can set the pixel using the setPixel function in the bitmap with coordinates x and y, and we'll pass an array containing a single color value, the surface color. After the x loop, we'll display the bitmap, which means that we'll update the bitmap after every horizontal line has been rendered, and it's going to look very similar to the way the scanline renderer updates a single line at a time. At this point, we have most of the rendering codes prepared except for the fireArray function, which is actually the major part of this script and is going to perform the evaluation of the color at the intersection point. We define the fireArray function. It's expecting a single view ray as parameter. We'll define a last surface color variable to the background color. The background color is a global variable which returns the color defined in the render environment dialog, in this case 0078. As you can see, it doesn't have an alpha value. In fact, it has alpha of 255. So in order to return a background color with the correct alpha, we're going to set the alpha to 0. Now we'll loop through all the objects in the objects array. We're not using a for loop directly for all in the objects do, because we're going to need the index to the objects array in later stages of the rendering. The object itself is going to be the element of the objects array with index O. Another variable, the diffuse lighting, is going to be initialized to black. This is the illumination at the surface point. In order to calculate the color, we'll first see if there is any intersection with the current object using the intersect ray x function with the current object and the view ray that was passed as parameter to the function. If the intersection is not undefined, then we'll have to evaluate the color at the intersection point. We'll loop through all the lights that we collected in the beginning, and for every light we'll calculate a vector pointing from the surface point that was intersected at the light source. We'll normalize this vector with end at the light position and start at the intersection the first element of the intersection